Okay, everyone, I think we're complete. The Paase Fireside chats naman are really roundtable discussions. We usually only have anywhere from 10 to 20 participants. No, we try to keep the group small so that there'd be more interaction with our speakers. No, at the same time, we're recording all the fireside chats of Paase as they form sort of like a library of discussions in the Paase website. No, so well, we're already complete. No, so in behalf of Giselle, who's having a few technical difficulties, I'd like to thank our speakers for today for agreeing. I'm sure Giselle arm twisted you to speaking today. And I also know that everyone is busy, no, lalo na those who are involved in the preparation of proposals for climate resilient cities call for proposals from USAID. So we'll try to keep our discussion within the time frame that was provided. Okay. Giselle, did you want to give some opening remarks or diretso na tayo?
Diretso na tayo.
Diretso na so that we can discuss right away, no? We'll have more time for discussion.
Oo. And I think that, well, first we will try to introduce our speakers, or
I'll introduce them one by one as they speak.
All right. So it's just, well, welcome to our Fireside Chat, episode 16 on towards climate resistant communities. I would like to thank our speakers for accepting the invitation to share your knowledge with us in this topic today. And I think it's a very critical time for us to come together to discuss this. And everyone would be happy to know that the speakers here would be involved in a proposal that will be submitted to USAID NOFO on climate resilient communities. I think it's climate
cities.
All right. So I hope this becomes a very productive discussion today. Thank you.
Thanks, Giselle. Aside from our speakers, I'd like to mention those who will be joining our discussion later. No, special mention to Raymond Tan of De La Salle. Hi, Raymond. Mr. Segarra of UP. Of course, Malu Ernie of NRC. Mr. Agapito and Mike Promentilla also from De La Salle. Thanks for joining us. All right, simulan na natin. Our first speaker is Professor Ino Lansigan. He's Professor Emeritus of UPLB. Congratulations on the retirement, Ino. And former Dean of the College of Arts and Sciences of UP Los Baños. No, Ino is with me at the National Panel of Technical Experts of the Climate Change Commission and is heavily involved in climate impacts in agriculture, among other things. So without much further ado, let's start with Ino. The floor is yours.
Okay, thank you very much, CP. Magandang umaga sa atin lahat. Thank you for joining us this early morning. Since the theme of our Fireside Chat today is towards climate resilient communities, I decided to talk to you about risk transfer mechanism as a climate adaptation strategy for resilience in agriculture. This is actually part of a big project on smart agriculture being funded by DOST. And we are, at this particular activity, we are collaborating with the Philippine Crop Insurance Corporation. The motivation for this topic are actually the following. As we all know, the national poverty incidence is about 26%. And a big portion of that is in agriculture. So if we can address that issue, particularly in agriculture, will be contributing to poverty alleviation in our country. And as you also know, agriculture is a risky enterprise. It is vulnerable to a number of uncertainties, both biotic and abiotic factors, particularly weather and climate. The latest estimate of average annual loss or damages due to extreme climate events is about 133.2 billion as estimated by PIDS. And another motivation is we're exploring the possibility of using climate risk financing and insurance as one of the most viable options in actually reducing the financial costs or shocks of damages due to typhoons and related climate hazards. And this is very much related to the initiative of USAID now on building climate resilient cities, wherein financing is one particular aspect of that big project. Well, climate change is now a reality, as we all know, and there are increasing local observational evidences that you can find based on records from northern part of the Philippines and the southern part of the Philippines. In fact, we have published an article on that, providing local evidences of changing climate in the Philippines. Well, as we all know, climate change is, affecting agriculture. Let me share with you some slides here. Okay. Oh, I cannot get it. Okay, just to give you an example, okay. Okay, climate change is actually results to about 10 to 14% reduction in crop yields for every 1 degree increase in minimum temperature. That is minimum temperature, not the average temperature. And study shows also in our Institute of Animal Science about 18 to 22% reduction in the weaning rate of livestock and about 20% increase in poultry mortality rate. And of course, I cited earlier, the significant losses and damages due to extreme events. Well, there are different responses to changing climate and climate variability. And I would like to mention here some adaptation options, particularly focused on agriculture. And one of which is actually using improved crop varieties. So this is the traditional approach. And the response is by introducing tolerant or resistant to climate-related hazards such as heat stress, flooding, drought stress, salinity, and so on. But another group of responses or adaptation is actually called risk transfer mechanisms. In other words, you share or transfer the risk to another person or entity. And traditional examples of this is our paiwe system for livestock, okay, wherein somebody provides the animal and somebody will take care of it and they split the profit later on. And of course, the Pacquiao Arrangement, and this is basically practiced here in Southern Tagalog region, wherein somebody takes care of the crop and will contract the owner of the lot or the orchard for the harvest the coming season. And then there is this arriendo arrangement wherein somebody provides or gives a businessman access to the use of the land for a certain number of years, usually at least 5 years arrangement. So we have these traditional risk transfer mechanisms. But of course, there is this traditional Agri Insurance products. This is actually being promoted by the Philippine Crop Insurance Corporation. And this is basically an indemnity-based insurance product. It has been set up since 1979, but then surprisingly, only about 15% of our farmers are subscribed to the Philippine crop insurance system. The reason is, well, it's not attractive to farmers and also fisher folks, and of course the insurance premium is also not so affordable to our small farmers and fisher folks. And besides that, only the cost of establishing the crop is covered, meaning land preparation, the seed materials for setting up the land is the one covered. And PCIC adopts the uniform risk profile, meaning assuming the same risk all throughout the country. So in this particular project that we are engaged in, we're exploring the use of the more objective weather index-based insurance product. And this involves development of indices based on some measurable weather parameters or climate parameters associated with crop growth and development, such as, for example, rainfall for drought, temperature for heat stress, wind speed for typhoons. I have a student working on insurance product for typhoons because we don't have that. And the next step is the estimation of risk based on specific index to address a particular climate hazard. Then, of course, related to the estimation of risk would be the differentiation of the risk profile, both temporally and also spatially. Temporal, meaning for different growing stages of the crop. So you can provide information to the farmer to choose from. If he plants on a particular day, what will be the risk involved, and spatial across different crop production areas. So different production areas in the country. So to define the index, well, we consider that in general, there will be three stages of crop growth: vegetative stage, flowering stage, and maturity stage. And there are corresponding periods associated with these different phases of crop growth. And you can define the water requirement of the crop based on the minimum of 5 millimeters of water per day or 7 millimeters of water per day, depending on scientific data that you get. And we have here 270 millimeters for vegetative growth rate, 210 and 180. And if these threshold levels are not reached, then the farmer is entitled to payment. So this provides estimates of water requirement you can consider, and you can determine this also for other crops. And the estimation of risk, well, this as an example for Los Baños, for this particular variety, of course, this probability of crop failure due to rainfall deficit would be crop specific and also index-based specific. And you can establish this for a particular location, for a certain crop variety, and also for a certain period of planting. So I just show you also an example of the geographic insurance unit that we established for selected locations, such as Isabela, Iloilo, and Bukidnon. So instead of using uniform risk profile, we can actually differentiate the risk profile based on topographical features of the area, or based on rainfall distribution pattern. And this is for Iloilo. So the usual practice is to have the same risk profile for the entire province, but we have shown that you can actually separate or delineate the risk profile into 3 or 4 groups. And this is the area of Glen in Bukidnon, the geographic insurance unit for Bukidnon. So you can establish this for particular locations, for different crops, and for different indices based on the climate hazards that you are addressing. Well, the Philippine Crop Insurance Corporation, together with DA, has actually piloted this the last few years, but it has never been implemented or rolled out even after that pilot projects that has been undertaken, because there are a number of challenges and issues on the implementation of the WEB products in the Philippines. Okay, I cited this some just to give you an idea. Basically, the problem is the formulation of adequate, appropriate weather-based indices and the estimation of this probability of crop failures using these indices. And of course, this is the work of the people in the academe or research development institutes like Phil Rice. The second problem that we often encounter is actually the paucity of weather data for major crops growing areas. And there are only about 70 synoptic weather stations of Pag-asa, which is only the accredited data source of the PCIC. That's the problem. PCIC recognizes only Pag-asa data. So even if you have a number of weather stations around the country established by local government units or state universities and colleges, if they're not accredited with Pag-asa, then that cannot be considered in the PCIC insurance system. So we need to do a lot of work on this, and we have been encouraging Pag-asa to help calibrate the weather data generated by other data gathering stations. And the third problem is basically on the relatively high premium for WEB products. The WEB system has less operational cost because you don't need an adjuster. In the traditional PCIC insurance product, you really need an adjuster who will really conduct the assessment whether the farmer is entitled or not. In the WEB, you just talk about the threshold, whether it has been reached or not, then that will be the basis of the payment. But one critical issue here is essentially the high premium tax imposed on the WEB products. Imagine 26 to 27% of the premium is actually tax. Oh, so the insurance providers in the past have been lobbying to the insurance commission to lower the premium tax associated with BB products to encourage them to be more competitive with PCIC. The other problem is, of course, institutional, because there seems to be a monopoly by PCIC as far as crop insurance products here in the Philippines. And of course, that leads to the need for institutional reforms in the Agri Insurance system as far as promotion of the WEB products in the Philippines with appropriate institutional support, including access to or the need for reliable weather data, and also the R&D on objective weather-based indices and insurance products, and including the speedy system of payment of indemnity. In the piloting that we did, farmer gets payment via ATM once the threshold has not been reached, and the farmer doesn't have to go to the PCIC offices to claim the payment. So these are some challenges and issues on the implementation of the WEB, and okay, we hope that the PCIC will really be introduce some innovations as far as its insurance product system. Let me mention here that there are some legislative initiatives on crop insurance. But then this is basically focused on mandatory insurance coverage for palay and other essential crops. And there is another bill by Senator Villar on establishing regulatory framework and program for a free WEB crop insurance coverage. So that's very encouraging. But then, okay, the funding for this insurance product is actually an issue. And then there is another Senate bill on the mandatory crop insurance coverage, particularly to help the small farmers as- from the national government in terms of providing subsidy. So indeed, well, there's also a couple of bills in the House on weather index-based insurance, and this much related to these versions of Senate bill in the Senate. Well, finally, uh, the climate and disaster risk financing and insurance is actually a viable option to reduce the losses and damages, particularly our small farmers and fisher folks. And there are opportunities provided by WIBI that we can explore. Of course, there are issues and challenges, but then this can be addressed through partnership and collaboration among the different institutions, particularly PCIC, the DA, even the academic research institutions, and also the private industry. For your information, there are now a few private entities providing microinsurance as well as weather index-based insurance, including Pioneer, the Card, MRI, and also the Balaya Insurance Company. And we hope that we can open the playing field with fair competition among the different insurance providers, including the PCIC. So we need everybody's help, but then we need science and technology to provide that improved insurance system to help our small farmers and fisher folks. So I think that's what I can share now, and I'll be happy to answer some questions you may have regarding WIBI implementation in the Philippines. Thank you, CP.
Thank you, Ino. We'll have a longer time for discussion later. Pero I have a burning question for you, Ino.
Go ahead.
And this borders on probably being politically incorrect already. Kasi you mentioned that the incidence rate of poverty is high among farmers. Uh, no one has actually done a study, dapat si Raymond ang gumagawa nito, of like a work time study in terms of how much hours do do farmers provide. I have a feeling that they do a lot of work at the start, preparing the land, not much work over the 3 month period, and again, a lot of work over a few days during harvest time. And so the way I see it is that we are not maximizing the time of the farmers in the middle of when the crops are growing. No, I don't think they put in 8 hours of work during that middle time. So if there's a way for farmers to somehow tend their farms during the morning, no, and then do something else, maybe vegetable farming or some other form of work, that will increase their salary.
Yeah.
What do you think?
Yeah, I think we need to provide alternatives to farmers to supplement their income. And as you know, farmers usually go to the field early in the morning, and then they stop at 10 o'clock, and then they will
Exactly.
probably.
Oh, wala naman silang ginagawa from 10 up to
That's right.
maybe 3 p.m.
That's right. So providing them alternative livelihood in between those periods will be a good strategy also for increasing their productivity and increase their income.
I think wala lang makapagsabi nun dahil baka it will be misconstrued as saying that our farmers are lazy. But in truth, that valuable time in the middle of the day needs to be productive, and this is time for them to earn. So
Yeah,
I
that's right.
challenge Raymond of De La Salle to do a study for that. Isama mo na rin yung mga tricycle drivers who are actually in the terminal doing nothing for most of the day. No, and therefore I don't see it why they're complaining of low salaries when in fact if you just count the number of hours of work, it's probably not even 2 hours. Anyway, and also the insurance issue, alam mo naman, yung mga Pinoy, we're averse to insurance. How do you think we should approach this?
Well, one thing is, of course, IEC, and the other thing is we really need to make the premium affordable. Okay, we need to convince the local government units to look to cover or provide some subsidy, because you can look at it as an investment rather than as a cost, because as you know, yung LGUs are spending so much in rehabilitation. So kung yung perang yon na representing about 5% can be used, or part of that can be used for providing subsidy or calamity fund, that will be an investment rather than the cost. I think we need to, but then we need to provide the framework on how to do that.
Okay, sounds good. Okay, thanks, Ino.
Okay,
Let's
thank
move
you.
on to our next speaker. I should also mention that there we talk about climate change at the time when we are at the height of the second wave of COVID, no? But in reality, climate change and its impacts will be of a longer term in terms of its effects. And it's just sad that it takes a backseat just because there's a more pressing issue that's also most probably related to climate change. In any case, when the rainy season for this year kicks in, then we realize once again that we are, other than COVID, super vulnerable to issues of flooding, no, uh, of which our next speaker is one of the premier experts in. Glenn Tabios is a professor emeritus of UP Diliman, also an academician of NAST, and has done so many work on water resources as well as flooding potential of our major rivers. So we'd like to hear from Glenn. I hope you
Thank
can
you.
share
Thank you very
a
much,
few
CP.
things over 20 minutes. Hi,
Yes.
Glenn.
Hello. I'm going to share my slide because are you able to see it? Maybe full screen. Are you able to see this?
Yes,
Yeah.
yes.
Okay, good. So I've got 5 slides after this. So I hope to finish in 12 minutes. That's what Giselle was telling me. So my talk is on urban flood risk management with changing climate. I hate to say climate change, but anyway, changing climate. And basically, I just want to bring up this sort of discussion points, or basically points to ponder, which are on urban dimensions of flooding. And I want to cite Pasig Marikina in particular. And then the need for transdisciplinary approach. And then the question of this inadequate design flood level of protection, which really affects a lot of our poor communities. And in the irony is that with changing climate, we have to even look at a much more bigger design flood. And that's, I'm going to talk about non-stationary extreme value analysis. And finally, I'll end up with some nature-based solutions to flooding. So let me start with these urban dimensions of flooding. As you know, in the case of Marikina River Basin, that's the Marikina River Basin is about 512 square kilometers, 520, I'm sorry, 30. So it goes down to Marikina City, the Marikina River, and then it joins Pasig River around here. But in 1982, they diverted these flood waters to Laguna Lake, which again, you basically transferred the flood to Laguna Lake because they didn't build the Parañaque Spillway. But if you look at the entire dimensions of flooding here, we have other, not only from the point of view of hardcore engineering structures, we're talking about the Magan floodway or even flood walls in Pasig River, but we have to look at the forest denudation, which has really brought in a lot of sediments. I was always talking about Tumana Bridge in near Loyola Grand Villa in Marikina, where maybe 2 to 3 meters had accumulated in the past 2 years. I mean, 10 years, sorry. 2 to 3 meters of sediment. It has shallowed the river that the Tumana Bridge, which is an overflow bridge before, it already disappeared. So that's one of the things. You really have to control sedimentation. Of course, we have this issue of local drainage because we have built around this area a disappearing river, garbage, and even the Mangan floodway, this one, is now reduced to from 260 to 220 meters because of these settlements on the embankment, And then, of course, you have even this improper land use zoning where, people live inside Laguna Lake. So these are other than, sort of a physical uh, problem. It's of flooding, but really social and economic, and then even human behavior. So let me go to the next slide. It keeps on telling me to remove this one. Anyway, so because of this complex issue of the dynamics, of the interaction of, and uncertainties of these different factors, you have the physical system, socioeconomic and human system. Like you talk about climate change nowadays, changing weather dynamics, even sedimentation, even ecological integrity of rivers are affected and so on. And then you talk about economic, socioeconomic, and I'm gonna put in, like, for example, I've seen as far as valuing human lives for flood protection, it's so small. I've seen it in Magad feasibility study. They only value human life 5,000. If you value 100,000 per person, then maybe you could justify the flood benefit of, let's say, a given flood control structure and so on. And of course, you have investment and financial priorities. I'm going to show you that later on, that we really do not prioritize flood control and so on. And of course, you have, again, the garbage, political ambitions, informal settlements, and even this culture of disaster, because we are so used to these floods. We accept disasters like that's the fate, the destiny of Filipinos and so on. So this is where I'm coming from, that because of all these different factors, it really takes various disciplines. And that's what we call a transdisciplinary approach where, sorry, it transcends disciplinary preconceptions, but is capable of, somehow I couldn't see the bottom part here, and so on and so on. So are you able to see this one? Okay. So I couldn't read it anymore. So I want to go to this question of inadequate design flood level of protection. If you think about the Philippines, the major DPW's flood control projects in the Philippines, look at Pasig Marikina, is only associated to this important parameter we use in flood design, return period. 30 years return period flood. Agno 10, and then Lawag 25. The only biggest one is 50-year return period in Ormoc because of that big debris flow that happened in the 1990s. All of these are so small. If you think about, even as far as the specific discharge, I don't see any relation between why only invest this much and the flood, the discharge per square kilometer in the given watershed. So this is something to think of. So if you think about the Moland barrier in Rotterdam, for example, they designed it for 1,250 year return period. And then in 5 years ago, they upgraded to 10,000. Can you imagine these kinds of investments? In the US, Mississippi, Santa Clara Valley, in the Silicon Valley, they designed 100 year, 200 year. Maybe in Silicon Valley is, because I've done work in California, 200 year return period. CP is familiar, maybe in the Palo Alto, all this redwood and so on. 200-year return period. That's how they value lives as well as properties, or even the Silicon Valley, of course, where is the seat of these big high-tech companies. And then we go to this, what we call climate change. We cannot even invest to the 30, 40 year. And then we go to this climate change issue. So this is one particular, I wonder if you see this, because I've got all this thing at the bottom in my, are you able to see the entire? Okay.
Yeah, we
Yes,
can, we
yes.
can.
Okay, sorry.
Yes.
In my case, I couldn't see it because I've got this thing mute and so on. But anyway, in flood control projects, I mentioned that design storm or design flood, which is associated to a return period or recurrence interval, is one of the most important parameters. In fact, if I talk about design floods, actually it should not only be a peak flow, which is what we have been doing. It should also consider the duration of the flows. Because like, for example, the Ondoy happened in about 3 hours, you get so high flow. But the Ulysses last time, it's a long, or even the Habagat, it doesn't flood in 2 or 3 hours, but after 5 days raining, you get the same magnitude of flood. But anyway, just looking at, let's say, this particular case, this is the rainfall of Cagayan de Oro, uh, basin rainfall of Cagayan de Oro River in Mindanao or Cagayan de Oro City, where, from 1945 to 2014, assuming that this is a linear trend, I fitted this general extreme value distribution and did the non-stationary extreme value analysis. So if you were to design supposedly a storm like the Typhoon Sendong, which was 187 millimeters, it's actually the 58-year return period storm. But if you wanted to design a structure in Cagayan de Oro River in the next 50 years with a sort of looking at the next 50 years with changing climate, you should design it to 273. Is that 273? Oh, sorry. 273 millimeters. So that's like if the project life is 50 years and then you retrofit later on or upgrade, you have to design it at 243. Or if you look at it from the point of view of risk, which is this equation here, in the next 60 years, if you want even just a 10% flood risk aversion, instead of designing the flood structures associated to 25-year, it should be based on the 50-year. That's basically what we're saying. And these are equations where you're showing the return period computation and the risk probability if you have a non-stationary extreme value. Finally, I want to just mention about urban flood control and climate resilience with nature-based solutions. So if we design our flood infrastructures, the engineers for that matter, we build hard gray structures. So there's like, you use flood walls, embankments, and even reservoirs, flood control reservoirs. But nowadays, in fact, the British or even 20 years ago in the US, the approach is that first, if you're able to restore, you restore. If not, you alter or modify. And finally, that's when you do engineering measure. So the nature-based solutions which are being advocated by, there's one capitalizing nature-based, is a Stanford University initiative. There have been people doing that for the last 10 years or so. But if you look at the nature-based solutions, the extreme, of course, is all natural. So basically, if you modify it, you bring it back to the old system where you have like you create, protect, restore ecosystem elements such as floodplains, wetlands. So you remove people maybe if they are in the floodplains and so on. So that's basically the objective is you will be able to store as well as to attenuate floodwaters. But you can also have a hybrid nature-based solutions where maybe to compromise with this. And these are basically, this is more actually climate resilient infrastructure if you think about it. Because you don't need to upgrade so much later on. You don't need to raise your flood walls and so on because you have a changing climate. Anyway, this will be a combination, of course, of your hard core engineering infrastructures with your ecosystem elements like this maybe some greenways or leave the river to the floodplains and so on. I mean, restore the floodplains and so on. So the remaining things are just in an urban area. You can do a lot of things, and these are like even now we call sponge city and so on. And in fact, we have this. I think Alvin and he asked me what we can do in Palo Leyte, where he comes from. Maybe look at some urban greens. In fact, from the point of view of climate change, in addition to flood reduction, with urban greens, it provides also carbon sequestration, urban heat reduction, and energy savings as far as climate change, in addition to your stormwater runoff reduction. So that ends my presentation. Thank you very much.
Thanks, Glenn. While you're speaking, and particularly on nature-based solutions, I sent you an email regarding, I think there are 12 nature-based interventions for flooding being done in the UK, and we're trying to localize it here in the country. So I sent to you that document. And
Yeah.
kung baka yung iba interested kayo, just let me know. It's a very interesting, parang one-pager documents about.
Yeah, are you talking about like if you look at the coastal, wetlands, urban, and rivers and forest, how you do coastal flooding, erosion, urban flooding, and stormwater, and
This
then
is
river
mostly
flooding?
river flooding.
Oh, okay.
Just river flooding.
Yeah, because I
Siguro
have
sa discussion, I'll show you some of the slides, but I sent it to you.
because
For
I have
your,
those in more detail actually what you can do from the coastal, urban, and river flooding. But in the interest of time, I didn't want to show so many things anymore.
Pero I think you hit it right on the point wherein our engineers, when they build these big structures, it has to be with a knowledge of nature-based intervention.
Yeah.
And the other point I wanted to tell you and not miss, pagka sinabi nating 50-year return period dapat ang design natin, or even 100 years, sabi mo, we multiply by 2 to accommodate risk, no? Dumodoble naman yung presyo ng structures. Is there a parang economic model that tells us that a 100-year return interval is the optimum in terms of ROI and protection? Meron bang ganong study?
Like for example, I've done a Pasig Marikina River Improvement Project about 15 years ago. So what I did was simulate for the 30-year return period flood, because that's what they were designing it for. And then DPWH requires that, you had a freeboard of 1.3 meters. Whatever you build, you add 1.3. And if you do simulation with that 1.3 additional, because that's the practice in the Philippines, there are only a few places along the Pasig Marikina River where it will overtop the levee. So maybe if you added some more, maybe it would have covered the 100-year return period flood anyway.
Okay.
So those are things that you have to look at. Let's say with the freeboard that they add as part of the design practice, it covers already. So you have actually minimized some risk. So although I mentioned 1:30, but there are areas that it's really 1:100.
Pero interesting yung effect niya sa cost. Baka naman yung 50-year na design, 50-year design, 50-year interval design, if you make it to a 100-year return interval design,
yes,
10% lang yung increase.
Correct. Oh, that's true. In fact, that's what NEDA is now requiring, that we have to do value engineering. And that's a practice now in the last 10 years only. So when you do a project, you just don't like already commit yourself to a particular, parameter and so on, but also do a sensitivity analysis. Maybe you need in a 10 billion project, maybe 2 billion more will already cover a higher level.
Okay, got it. So I learned the new term from you today, value engineering.
Yes, that's been.
Tama pala yun. Okay.
I have done value engineering for West Mangan floodway, Pasig Marikina, and even Cagayan de Oro River 5 years ago in Cagayan de Oro City, actually.
Okay.
Okay.
All right. Thanks, Glenn. Marami pa kaming tanong sa iyo mamaya during
Thank you
the
very much.
discussion. Thanks. But it's a really good segue to our next speaker. Tony Yulo Loizaga is the current president of the National Resilience Council, also a member of the Board of Trustees and former executive director of the Manila Observatory in Ateneo. I asked Tony yesterday to talk about the non-technical, non-scientific interventions that we need to provide, to combat climate change. This is, I guess, your expertise, Tony, and us scientists and engineers, we definitely will be able to learn a lot from you.
Thanks, CP. Thanks for that introduction, really non-technical. I told Giselle when she first invited me that I feel a little bit like a fish out of water here. No? All of the physical scientists are present and members of both NAST and PAASE, and data scientists as well. My background is in political science, political scientist. And at this point, our emphasis at the National Resilience Council is how do we build or help LGUs build evidence-informed decision support systems. So necessarily that would mean that we need to link them to the technical, academic, and research resources that they need in order to make informed decisions and take action in terms of climate change and other hazards as well. I'm just going to talk over a few points, basically, and then show you a little bit of who we are. But my first point, I think, is what we're looking at in terms of climate resilience and basically adaptation mitigation is a change in behaviors. We have a brain trust in PAASE of knowledge that has been established over years of research. But how does that brain trust actually change behaviors at the local level? And there we have two different dimensions in terms of the way decisions are made. You have the formal decision-making processes, which are linked to the organization of the local government and the link to national government. Then you have the informal decision-making processes, which are actually a part of the culture of the local government or the city. And this is where we have the greatest challenge as far as the work of the National Resilience Council is concerned. The first thing that we need to do is to start where the cities are, where the LGUs are. The important point here is to establish whether or not those that are in charge of risk governance, climate risk governance, own the problem. If the LGU chief executive does not own the problem of climate change and climate resilience, we are halfway not there, basically, okay? No amount of linking to the academic institutions, the research that's available will help this LGU, okay? So the first learning that we had when we began to work with the cities is, does the LCE, the local chief executive, and the team own the problem of climate risk and the challenge of resilience? So that was the first learning. The second one is, how does the local government work? Are they in silos? Typically, all the local governments work in silos. So that was a second issue. When you presented, Glenn, transdisciplinary research as a way to approach this problem of resilience, social, cultural, economic, physical, the way local governments are structured are in these silos. So thinking across the different silos is not typical, and certainly not along the different decision-making levels where you have mandates and authorities that are different, depending on your pecking order in the local government. So that's another learning. The third point I wanted to share is that we approach the work of resilience, and this has to do again with the transdisciplinary approaches that you mentioned earlier, Glenn, looking at the intersecting social and physical geographies of risk. And there are two transects in particular which we've adopted as the basis of our framework. The first transect is the Ridge River Reef, and that has to do with all the natural ecosystem boundaries and the physically available natural resources that are within certain boundaries that the LGU, politically administrative boundary, will have control over. So, and those differ, basically. The political administrative boundary don't match the natural ecosystem boundaries. So that's the one transect that we have to work with, Ridge River Reef. The second transect is the human cost transect, the human influence transect, which is the rural, urban core transect. So this involves human systems, engineered systems, etc. When these two transects collide is where we have the kind of risk Glenn so clearly established in terms of cities. And I know we've talked about this before, and we've worked in some cases, both with UCP and Mahar in other cities as well. So the two transects really led us to begin wondering about what's the framework? How do we approach framing the climate and other hazards resilience framework for local government units and communities? And what we came up with is a framework that has 5 pillars and a set of outcomes that we need to present to the LGUs and have them embrace. The first pillar, and the most critical, as I said, is the leadership and governance pillar. They need to have that inclination, that openness to evidence and engagement with multiple stakeholders, not just their own within the government. So internal and external stakeholders. The second pillar is the human development pillar. And under that, you have education, health, social protection. We need that pillar to be first. The next pillar is local economy. And that runs from livelihoods all the way to big business, big corp. The third is actually infrastructure, lifelines. So built systems, the built environment, households, buildings. The fourth is actually environment, ecosystems, natural resource use, conservation, pollution control. The most important pillar for some of the LGUs is the last one, which is human security. And that has to do with physical security, criminality, external threats, conflict, fragility in terms of social fabrics. And that all these pillars are interrelated. And convincing them of that has been the biggest challenge of the National Resilience Council. The outcomes that we're looking at, not just the minimization of risk or risk reduction, but really development continuity, achieving the sustainable development goals, and of course, resilience to future risk in the long run. So that framework is accompanied by a set of metrics. And this is the next element of the approach of the National Resilience Council. We need a way to measure progress. The program that we have running now in 8 LGUs, and we're about to launch in several more, okay, really has 3 years involved. Prepare year, which involves the climate and disaster risk assessments that need to be established as the baseline condition for each of these cities and the provinces that we work with. The adapt year, which is where we are in most of the cities now, is really looking at their existing systems, including their annual investment plan, and seeing how science has played a part in guiding that investment plan. Yesterday, CP talked about socialized pricing of water. Okay, and this is something that is for our adapt year. How do they modify their existing processes and decision making on investments within the planning and budgeting process of each of the local governments in order to reflect the risk that they have established in the prepare year from the climate and disaster risk assessments that they have done? And lastly, the transform year is where we have changed institutional arrangements. And I'll talk about that in the second. But that has to do with junking whatever is no longer useful and establishing the kind of research questions and priorities that are needed in the process of understanding what is needed in order to become climate resilient, and the policy inputs that are necessary to actually answer the questions that you have presented on value engineering, CP, to Glenn. So the transform year is where we will address those questions. Now, there are two tracks to the program. The program has a science and technology track and a leadership and governance track. We cannot separate the two. Otherwise, we will have business as usual. And that's where our challenge is. We continue to deliver science and technology modules together with leadership and governance modules and link the two. For the first year, it was really training the LGUs to generate their own CIDRAs, their own climate and disaster risk assessments, tapping resources from academic partners locally, and where that's not available, tapping, for example, CP in terms of water security in Zamboanga City. We've had that experience. We need to be able to link academic and research institutions to the decision-making process, and that happens at the outset of our program. So each of the academic partners are matched with their local governments, and they must have a science and technology and leadership and governance leader. So right now, the ADAPT year, the main science course is a deepening systems thinking course, which is an introduction to qualitative and quantitative approaches to systems thinking, system science. And we hope to link that. In fact, it's ongoing in terms of the preparatory for them to enter the certificate course that will be delivered by Ateneo. We hope to link that to their annual investment planning process already. And so that third year, transform year science and technology component is what we call asking the right two questions. What are the research questions that you as an LGU will now need in order for you to make the transformations that you need in order to become climate resilient? I should just possibly end by maybe pointing out two components of the work that have been especially challenging. We are able to access scientists, engineers, to talk to us about the physics, the chemistry, the biology of hazards, and the mechanics of the way engineered systems work. We do not talk enough to social scientists who are able to deconstruct vulnerability and the perception of vulnerability among communities in order for them to be moved to take action. And so vulnerability analysis is one of the core elements of our work, and that's social vulnerability in particular. The last element is the role of the private sector. And here's where strategically perhaps we might be a little bit different. We look at the private sector as a co-implementer, and therefore their investments must be aligned not just to their own resilience and their own business continuity, but the resilience of the city. And this is work that is ongoing with several corporations. And I'll just, if I may, maybe round up by showing you where we are actually and who we are in terms of our work. May I share the slides?
You may. You are. We are on multiple sharing.
So are you able to see the slide? Sorry.
Yes.
So
Yes.
this is the framework I spoke about. So we work in each of these pillars. So at the LGU level, they must identify what we call local resilience pillar champions. And each of these pillars are part of the teams that we work with at the local level, along with the team from the academic institution that is a partner. This is who we are. I just wanted to take a minute to introduce who we are and how we work. We are co-chaired by both the private sector and the government. And we have four vice chairs, excuse me. That's the DILG, Ed Chua of the Makati Business Club, Father Jet, and Ernie Garilao of the Zwillig Family Foundation for CSOs. So we have government, private sector, academia and research, and CSOs in terms of our work. These are the current LGU partners. We are in the process of documenting another 4 that will be entering the prepare year. And these are the academic partners in each of those LGUs. And finally, these are our main private sector partners. They fund the programs of the National Resilience Council. And we are part of, we are part of the group with Giselle and you all, as you know, on the ASU proposal. We are also part of a consortium that is led by UNDP that is part of a 6-year program now, already in implementation phase, initiation in the beginning, on resilience as well, called SHIELD. It's an Australian government program, $18 million over 6 years, and is looking at practically the same issues in terms of the resilience of local government systems and what they would need in order to become climate resilient in the future. So that would end my presentation, Sips.
Thanks, Tony. I wanted to ask you quickly, among your LGU partners, which one would you say is most proactive, and as how you said it earlier, who owns the problem, no? Who readily owns that problem? Who would you say among your LGU partners?
Actually, they all do, but I'll say maybe champion-wise, Abet Garcia, of course, as a provincial governor, Abet.
Bataan.
Okay. Beng Climaco of Zamboanga City.
Meron bang common characteristic dyan sa mga yan?
They have a long-term vision for the province.
And speaking of long-term vision, jokingly, I told you once that moving forward, a viable strategy that we should take is to start rounding up and training the kids of these traditional politician families and start them in that training path, because eventually they'll be the next mayor and governor. So catch them early, kumbaga.
Sure. And I think that's a really good suggestion, Sips. Talk about social engineering for resilience. Yeah, we can actually fast track the young ones. Yeah,
there are a few families lang naman that are still in control, diba? So
and I think
pwedeng simulan.
It's a very key insight kasi the power relationships are really what cause the inequities and can also transform them if they want.
A more enlightened leadership, no, in the future. Okay, thanks, Tony.
ICB, can I have the first question, please?
Quick question, and because we have to move to Mahar's talk now.
Oh,
go ahead, Raymond.
Okay, No, it's fine. We'll do it.
Okay, sige.
I thought it was the Q&A already.
No, I'll have you as our.
Naka-reserve na ako for the Q&A.
Yes.
Okay, thanks.
Also, quick mention to some of our participants. Cora Claudio is here. Hi, Cora. Dr. Raimundo, Dr. Virgie Cuevas, and of course, Dr. Raul Fabella. I was just reading your column, by the way, Dr. Fabella, about the exodus of manufacturing. Okay, let's move on to our last but certainly not the least of our speakers. Dr. Mahar Lagmay is the Executive Director of the UP Resilience Institute, also a professor in NIGS in UP Diliman, and an academician of the NAST. Mahar, maybe for the last 10 years or so, we've been doing disaster science. Meron ka pa bang natututuhang bago, no, after more than a decade of working in this field, or looks like you're still not getting frustrated of the changes that are required? So we want to learn more about your current work and insights, no, on disaster resilience. Go ahead, Mahar.
Thank you very much, CP. Actually, I'm not frustrated. Well, I was frustrated, but I was able to be able to recover from that because of an encounter with a Japanese professor that I had. No? I had met recently. By recent, I mean probably 2 years ago or 3 years ago. And he was the head of the Disaster Institute of the university. And he was telling me that they had introduced some changes in the disaster management program of Japan. And he said that before people could accept it or the government could accept it, it took 20 years at least. So there's this time lag between introducing what scientists are saying and the acceptance of what we are trying to introduce. And I also share the sentiments or what Felino said, Glenn said, and what Tony said. You are right. You are on the spot. When Felino said that when they were looking at the agriculture side for the weather-based insurance system, and then we had only 70 stations, that is really not enough. No, technologies are quite low. They're low-cost technologies, and all we need is to calibrate it and complement it with other knowledge, like, for example, the satellite imagery, the flood models of Glenn. And Glenn was also said that we are designing things inappropriately, under designing things, like we have 25 50-year rain return floods, and these are simply not enough. Come the time when these big floods happen, then those costly infrastructure interventions will not mean anything. Probably for the moderate floods or low floods that will work, but for the big floods, it might lead to a disaster. And I also observed that in the same way that Tony observed that it really depends on the ownership of the LGU, no? On the leader, and that there are many silos within the LGU. We have been working with many LGUs. No? We have worked with many LGUs, like, for example, in Laguna, in Mahayhay, in Naga City, Cebu, municipalities and cities in Batangas, in Bataan as well, in Nueva Ecija, and the observation is the same, exactly the same as what Tony said. So I share all of your observations. They are on the spot. But I think what those observations tell us is that we really need to work harder. Going back to your question, whether I'm frustrated, I know I've been working with you. We are all frustrated, but we have to carry on. We have to do really something about it. No? And linking that to what the professor said from Japan, it takes years, more than a decade, perhaps 2 decades before there is final acceptance. So maybe we have to wait until we retire. Si Glenn nag-retire na, but he's still emeritus. So meron pang several years si Glenn. Kami ni CP, meron pa kaming 1.5 decades, no? More or less. Yeah. Nandito pala si National Scientist Pabella. Hello, sir. Okay, so I'll be talking about, maybe if you allow me to share my slides, I'll make it quick just to anchor on the point, no? To add to the observations that were given by our first three speakers. Stop. So I don't think I can present this. Just a minute.
Try again.
All right. Do you see my screen?
It disappeared. Try again, Mahar.
Okay, I'll try again for the last
May
time.
ulit, Mahar.
Sige. So I'll make it quick after that introduction. Kita na?
Yep.
All right, good.
Yes.
So it's about towards building climate resilient communities. No? And we all know that we are in the typhoon belt. We are also in the Pacific Ring of Fire. We have volcanism. We have a lot of earthquakes. Basically, what I'm saying is that we have to deal with almost all types of hazards in our country. And that makes our country as a natural laboratory for studying disasters, hazards as well, that may or may not lead to disasters. Practically everything about hazards and disasters and natural hazards, I mean, we have them except for those related to snow. Now, we've been studying this for probably more than 2 decades already. And we found out that every time that there's a disaster, the people say, the victims, the survivors would say, first time this has happened, got surprised, hindi pa nangyari itong ganitong klase. No? All the time, every time nagkakaroon ng disaster. We've been working, CP, we've worked in Mindoro, bumaba tayo ng helicopter, natandaan ko. Hindi ko alam kung ako yung nagsabi no, ikaw yata, pagbaba natin ng helicopter, sabi mo, huwag kayong mag-alala, ligtas na kayong lahat, nandito na kami. Tama ba yun, CP? Ikaw ba yun o ako?
Ikaw yan.
Uy, Mindoro, kasama ko dyan.
Yeah.
Oh,
We worked
si
a lot
Tony
with
ang
Tony,
nag-secure
no?
ng
Several-
helicopter natin doon.
So we've never seen this kind of flood before. Wala pang nangyaring landslide. Even the mayor would say that. We did not expect storm surges to reach that far inland. Hindi pa nangyari ito. So we might try to make sense out of this observation. And it tells us na if you analyze it, that means that we failed to anticipate. Just like any accident, a car accident. Ay, akala ko hindi dadaan, na surprise. And that happens too in disasters, no? During disasters. We thought that it would not happen. Tapos nangyayari, no? It's an event that caught us by surprise. Maybe we didn't expect that to happen. For natural hazards, these are normally the events that are bigger than what we have experienced. And this is actually the solution to this, we think, is already embedded in the Philippine Development Plan. So if I did a screenshot, it says here, appropriately scaled probabilistic multi-hazard maps. We need that. And it's also in the climate risk management framework of the CCC. Probabilistic climate risk assessment, or what they call SPCRA. So just to give an idea of what this means in terms of the disaster perspective, when we make hazard maps, this is the advocacy really, what CP and I have been doing for some time already, is that we always base it on the historical record. We base it on anecdotal accounts, what people tell us how big the flood was or how high the storm surge was. and so on. What we really need to do is to create more scenarios than that. So that is essentially, in the disaster perspective, what probabilistic assessments mean. We need to create multiple scenarios, not just one scenario, which is based on the historical record. We have to add more. And by adding more, that means that we are able to visualize using the science of hydrology. We have many scientists here in the Philippines, like Lino and Glenn. We have to represent that, and get us and the LGUs to visualize the scenarios that may be bigger than what they have experienced. So maybe some areas haven't experienced a 100-year flood. If they only plan, for example, a 25-year flood, akala nila malaki na, come the time na 100-year flood, tamaan sila, what will happen is that if there's a disaster, sasabihin nila, we did not expect this thing to happen. And also, there's climate change. According to scientists, they're saying that the typhoons will be more frequent, the rains will be stronger, and therefore will be spawning bigger floods, and will be generating more landslides or triggering more landslides. And this is how we plan in the LGUs. For most of the LGU cities and municipalities of the country, except for those with really good funding, they have access to consultants that can generate the more expensive probabilistic flood hazard maps or the other types of hazard maps, which is normally used in the insurance industry. So if we are dealing with a map that is only up to the historical record, largely based on the anecdotal accounts of people. Like, for example, in this map, this is a single scenario one. They're called as deterministic maps, in the disaster perspective. The yellow in the figure that you see is a low landslide susceptible area. The green is a moderate flood susceptible area. The violet is a high flood susceptible area. And the apple green is a low flood susceptible area, represented in colors. You can see somewhere in the middle part the poblacion, and radiating from the poblacion are streets with houses reflected in the map that is depicted in apple green color. So that means that they are in an area that is low flood susceptible, which is a low flood susceptible area. Now, we asked them, if you have an evacuation center, where will you put it? All of them said, this is an actual case, by the way, in a municipality that we did. One of those 34 municipalities in Leyte and in Samar. Now, all of them said there, okay, that's fine. It agrees with the map, which is largely based on anecdotal accounts that's being used for the country. But if we look at the several scenarios, that would agree with a low type of flood. However, if we overlay the bigger scenarios, like a 25-year or 100-year, even bigger, we can see that that evacuation center will get flooded. So if it was an evacuation center and that bigger flood happens, chances are those people in that evacuation center will die. And if there are survivors, what is the most likely statement that they will make? Hindi pa nangyari ito. This is the first time we've never seen a flood like this happen. So the result is we are putting them in places that are not safe, or we may put them in places that are not safe if we don't do the multi-scenario visualization of the hazard. Now, ano ba nangyayari pag nagkaroon ng disaster? So people, it's easy to do the blame game, di ba? Blame game, o turo natin ganito, ito, sasabihin, mahina si Mayor dahil sa corruption. This one is very easy. It's because of climate change. Hindi maintindihan, English ka pa ng English, walang action, kulang sa pondo, si Mar Rojas ang may kasalanan dahil sa mining, pinutol ang mga puno, kulang sa plano. But if many are true, no? Some are outrageous. But really, if we look at the problem, it's really, we think, as the failure to anticipate the bigger events than what people have experienced. And we need to solve that. And the solution is really already in the Philippine Development Plan. It's already in the CRMF, or Climate Risk Management Plan. All we have to do is to do the scientific execution, diba? And to do also, or convince the LGUs that these are what are needed. So, yun na naman, babalik na naman tayo like the problem. Kailangan official, like what Lino said. No? So that is, I think, as a stumbling block. So it's not about just evacuation centers when we talk about probabilistic assessments, no, of multiple scenarios. When we do plans for the LGUs, it must be made to cut across all sectors, because disasters would affect all sectors, as we learned from this pandemic. The planning must be in agriculture as well, coastal concerns, water, health, forestry, biodiversity, environment, energy, education, tourism, infrastructure, settlement, and perhaps mining. So kailangan, it's all integrated. It's not, the planning is not just for the evacuation centers. We know that from the pandemic, it hit almost all sectors, hitting heavily tourism, education, and the health sector. Now, I think I'll end there. I have more slides. I wanted to show more examples. But by ending there, I would like to emphasize that maybe the message here, or the takeaway, is that we have to do probabilistic assessments, no? For the LGU to select the risk that they want to take. And that risk that they want to take is largely also dependent on the finances that they have. And all of these planning, if we do all plans well, having a visual scenario of the hazards, we can get the community to plan well. And by moving
Mahar, we can't hear you. Wala yung audio mo, Mahar. There.
Those are the structural hard interventions that we need to make. But by planning well, we can actually make use of a lot of what Glenn calls as natural interventions. No? Ang tawag niyan, for example, sa Netherlands, yung river, there's a movement now. They call it for rivers, make room for the river. So they plan that floodplains remain as floodplains and not as settlement areas, to accommodate to the flow of the river during times of high floods. It's really a big problem. Not just in terms of the number of municipalities that we need to help. No? There are more than 1,634, maybe 1,700 cities and municipalities. And that's a lot of work. We've helped so many municipalities, and I know that we cannot do that for all of the cities and municipalities of the country. The problem is huge, and we need all the hands that we can have. So we have to work together. Kasi if not, there will be a disaster that will happen in one of those cities and municipalities. Because from our research, mukhang lahat naman ng Philippines is under threat. Thank you very much.
Thanks, Mahar. I think ang problema ay even if you provide the LGUs all the maps that they will require, there's no penalty for the local chief executive for not implementing these suggestions. So wala tayong pinangahawakan if they don't do it. So that's
Hindi, meron. There are SIPs meron, DILG looks at the disaster risk management plans, the climate sa SIDRA. They are supposed to comply under the law. But yun nga, ang problema, yung tinitignan nila.
Wala pang natanggal na mayor or governor.
That's the problem. Ang problema pang isa is that yung ini-implement in most of the areas are not probabilistic scenarios or multi-scenarios.
Okay. It's an uphill battle, but at least there's the groundwork already for that. Thanks, Mahar.
Right,
I'll give way to Raymond. Raymond, did you want to comment on something you heard or a question to our speaker?
Well, specifically for I do agree that agriculture should be part of the climate change adaptation discussion. My comment, my 2 cents worth really is a lot of the local discourse on climate change adaptation tends to look at extreme events rather than the average. So I'd like to raise this question, and perhaps Eno can comment afterwards. What about the slow creeping changes that we expect? It should be like Metro Manila traffic, which gets worse and worse every month and every year. And you don't actually notice how it's changing unless you look at pictures from a decade ago. So I think the danger is that there is going to be in places where traditionally this particular crop is what has been grown, and likewise for fisheries. This would happen as we get more ocean acidification, where normally you'd catch a particular kind of fish, but as ocean chemistry changes, you get less and less of it, but not enough for it to be spectacular and eye-catching. So what you see
we
is
usually don't react to those, yung mga dwindling,
Yeah, exactly, and it has happened historically. Mesopotamia, the cradle of civilization, is now a desert, whereas it used to be a breadbasket. So I think as the science community of the Philippines, we should be the ones with the knowledge to know things that the normal person would not normally think about. So maybe crop shifting could, please comment on crop shifting as a
good point,
potential
Raymond.
strategy.
Yeah. Meron ba yung research na yung the slow onset aspect of climate change?
Yeah, we have, okay, can you hear me? Okay, so we have research on that, actually for flood frequency and also drought frequency analysis together with our colleagues from UP Diliman, Sheila Gay Perez and her group. Okay, yung comment of Raymond regarding the average events and extreme events, that's basically what Mahar raised earlier on the use of probabilistic assessment, because you can actually define risk in terms of different return periods, and that's what the insurance product that you can propose. So you give options to the farmer. Okay, if you plant on this, there is a certain chance of risk occurring or this event occurring. But then if you plant later, there is this risk analysis that will let you decide which particular insurance product you're getting. Okay, so, but then under a changing climate, we note that the extreme events are occurring more frequently. Okay, for example, if you recall yung Milenyo sa Los Baños, for the first time in the history of UP Los Baños, we received 348 millimeters of rainfall in 6 hours. That's the time when IPB biotech area were flooded for the first time in the history. Okay, so that has not been factored in as far as the design of those buildings, because those buildings are actually in the floodplain areas in Los Baños, Bai area. Okay. Now, as far as the question of Raymond regarding shifting crops, well, that's another adaptation. Okay, you shift crops if you know that you'll have drought episode occurring in the next 3 to 6 months. That's one strategy. And so basically, the recommendations should not be blanket recommendations. In the past, DA are always been recommending blanket recommendations. Like, for example, you plant this particular crop. So yung sugarcane area, papaltan ng corn. And then later on, yung corn area, papaltan ng sugarcane in the entire... so maraming history ganyan. Yung fertilizer recommendation, sasabihin sa'yo, so you apply 2 bags of fertilizer all throughout without considering the indigenous soil fertility level. So mga ganun ba? So the point is, yung I second the motion of Mahar that we really need to update our probabilistic assessment of things, particularly extreme events, and hopefully we can improve the way we respond at the LGU levels.
Okay.
Thank you.
Thanks, Ino. I think yung isang point ni Raymond, yung very, very slow decline of productivity na this year 95%, the following year 93%. It's just too slow, and the incremental change is just too little for us to react. No, yun yung baka magandang pag-aralan yon. Before you know it, after 10 years, your productivity is down by 20%. Pero hindi ka pa nag-shift. I think yun yung isang point ni Raymond. So maybe in agriculture, that's a very important aspect. Glenn, you wanted to say something, and then Cora.
Yeah, I just want to comment on that because way back in 78 to 82, National Water Resource Council had this water resource inventory and then water plans for the entire country, UNDP project under NWRC, which is now NWRB. They have studied all over the country they define your water calendars. Different parts of the country have different timing as far as rainy season. But NIA, when the NIA came in, the rice irrigation, mga 1.7 million hectares, all over the Philippines, halos pareho yung timing ng cropping seasons, which is crazy. Yeah. So, because it's time to the fiscal year, just like when you talk about water boundaries, it's political boundaries, not water boundaries. So that's an issue. Yeah. By the way, I just want to mention also maybe Mahar is related to yung probabilistic. And both of us came from Colorado. We did a lot of stochastic hydrology. It's really beyond probabilistic approach now. You really have to index in time and space. So we call it stochastic. Just for example, in the case of yung sinasabi ko, Ondo, it was a big flood, pero in a matter of one shot now. But you look at in Magat 2 months ago, you have Quito, Raleigh, Ulysses, sabay-sabay sunod, just like in Peping in 2009, where you have 3 times pabalik-balik doon sa Agno River. So those are like episodic floods. Pero parang it's a series of floods. So you cannot just look at it from a one-shot point of view.
Parang hindi dapat single event ang tingin natin.
Hindi lang single event. And which is the problem with our design. And when you look at scenarios, it cannot be like yung sinasabi ata maybe related to Raymond, where it could be a slow onset, just like droughts, which we never really look at it also. But in the long term, there will really be changes, just like shifting seasons na bale. I've seen that of course, Mindanao has always been parang uniform all year round as opposed to Luzon. But there are parts of Luzon na nag-shift talaga, and I've seen that in Angat River Basin.
Yeah, magandang point yun, Glenn. In fact, sige, I'll look at the data set again.
And one last thing.
Sige.
The case of Mindoro, I don't know if you were talking about the 2005 floods, bale. Because I was also involved in that after a month or so. When we look at carefully what happened, they were explaining in terms of because of forest changes and so on. What really happened is in 1994, there was a big earthquake. And then nagkaroon ng uplifting dito sa eastern part of Mindoro. So the Magasaon tubig was captured by Bukayo River. But you don't see that until after mga 10 years. Nagbago, nag-shift yung river because of landscape change. not because of climate or anything.
Ah,
And
good
people
point.
did not realize that. And in 2005, there was a big flood, a series of storms again yan. December 7, 14, parang 7,
Oh,
14, 15, 21,
yeah.
28, I think that's when Calapan was isolated. I mean, the Nauan was isolated from Calapan. But that's, again, natural massive earthquake-based land change. Nagpagod talaga yung topography. But the same thing with Mount Pinatubo. Of course, that was a more drastic na nagbago. Pero
Mm,
the effects of the changes in the river landscape was not felt until after mga 5, 10, or 7 at 15 years.
yeah.
Thank you.
Hindi nakita yun, no?
Hindi
Na
agad
that is
nakikita yun.
a
It's a
factor.
slow onset change.
Multi-hazard. Si
CP.
Mahar champion yan. Yeah, go ahead, Mahar.
CP, can I add to
Sige.
what Glenn said, no?
Yeah.
Yung example ni Glenn do sa Mindoro, no? I have a student now who's working on what we call as complex or and cascading hazards. Your example is a very good example of cascading hazards, and we will include that in our database. No? Medyo mahaba, ang daming ganon, pati Pinatubo, maraming ganon. And I agree also that we have to, that's more advanced what you recommended, na it must be integrated with the space and time. No? So one at a time, gawin natin, and then let's try to do. Kaya nga sinasabi ko, marami talagang trabaho. There's really a lot of work for everyone to do. So kulang pa tayo dito, and to be able to help all of our cities and municipalities, we really have to work together. Not just the scientists. I agree that it has to be transdisciplinary because we have to mainstream the information to the LGUs.
Okay, thanks, Mahar. Good point. Cora, you wanted to ask something? And then Tony. Cora? Okay, baka nawala si Cora. Tony, you wanted to...
Hi. Can
go
you
ahead,
hear
go
me?
ahead. Okay,
Can you hear
yes.
Yeah, I'm just using my cell phone and I'm using my canned picture because I just woke up. Okay. In dealing with risk, it's very important for us to have a good warning system, right? I hope you agree. Are you happy, to the panelists, with the state of warning systems that we have in local communities and even nationwide? And is there anybody working on this? And are we including assessment of the risk perception of people that we are developing or we have developed a warning system for?
Good question, Cora. I think the best person to answer that would be Tony.
CP, put me on the line. But maybe before I answer Cora's, hi Cora, question, I just wanted to say, baka nakalimutan na ninyo ni Mahar that the Mindoro analysis included work also by John Ong and Ando. And lumabas, lumabas yung shift. True. Lumabas yung shift in the final analysis of the causality, no, of the floods. So I think, Glenn, yun siguro yung also that you have just mentioned.
Yeah, that time John Ong I was a member of his committee kasi si John Ong.
Yes.
Sa NICS during the test. I knew, he told me about that. Yeah.
Yes. So lumabas rin yun. Yeah, lumabas. So I just wanted to just recall that. On early warning, I think that there is a Pag-asa project that is funded by the Climate Fund and by WMO originally, I know, that was to recraft the warnings that they deliver relative to the systems that they are, calling attention to in terms of the hazard, no? And they were trying to inject risk into the warning, the wordings of the warning. Unfortunately, I don't think that yet has been completed, or I don't see it in the warning, and in fact in the delivery of the reports from Pag-asa. It's still largely hazard based, and I wanted to raise this point, no, in relative to silos. Pag-asa is a hazard science agency, di ba? It is not a risk management or risk reduction mandate that they have. NDRMC OCD, okay, actually would be the unit that should deliver a risk-oriented warning. And Mahar knows this. In the previous administration, there was a PIDRA system under Yusek Pama, no, Alex. And that PIDRA system really was hazard-specific, time-bound, place-based, etc., and had to do with exposure as well as some vulnerability, no, in terms of the assessment. So as far as warnings go, we still have a way. We still have ways to go. One of the points I normally text NDRMC OCD Yusek Halad is, can you supply us with accumulated rainfall and tidal information when you release the warnings of Pag-asa as well, no? Because then people can also say, oh, it's been raining for so long and this much has actually been recorded as having fallen on the ground, and the tides actually will rise and fall at certain hours, and so therefore we will be more susceptible to suffering that flood. But I haven't been successful in influencing that process. So in terms of the technology that's available, I think I leave that to the meteorologists to comment on. But certainly, I'm not quite sure what happened to the Doppler in Catanduanes during the three typhoons that passed us in November, and whether it remained up or is down. But there was a time, I know, when I was at the Manila Observatory where we were blind in that Doppler for many years because of some agreement with JICA that didn't allow it to be repaired in a timely way. So yeah, I'll leave it at that.
Okay, thanks, Tony.
CP.
Go ahead, Mar.
Can I request to answer because I have to leave? I have to
Sige,
leave
sige, go ahead.
already. I have another talk. No? Regarding the question about yung early warning, no, I agree with Tony, Yusek Pama, who I know is working with Tony right now. NDRMC had the system before called as the PIDRA system, wherein it states in that kind of system that warnings must be made in an exact manner. Parang it has to be hazard specific, area focused, and time bound. And to be able to do that, you have to complement the forecast data of the warning agency with near real time data, which will give you hours in advance warning, but or information, but it's highly reliable kasi it's ground-based data ng water level increase at saka yung rainfall amount that is being delivered. No? And of course, yung ginawa ni CP, yung dati, yung ano ba yun, yung Climate X, no? Making use of Doppler to predict the probability of rainfall in a particular barangay or particular watershed. That was very accurate and that was very helpful in the PIDRA system during the time of Pinoy. No? That was used during that time.
Mar, the other aspect of PIDRA, and I'm sure you remember this also, Tony, is that we do provide the hazard, no, to the specific LGUs who will be experiencing this, but at the same time, prescriptive na. These are the things that you have to do. Ganun na yung sinasabi ni Yusek Pama nun.
Barangay level.
Wala nang tanong-tanong, wala nang, okay, so and so millimeters of rainfall, this might flood, etc. Barangays 2, 3, 4, 5, evacuate.
Alis kayo dyan and move to a certain place. Yeah, that's right. So in addition, about the early warning system, we're trying to introduce the concept that the early warning is not just about what the agencies say. No, this is probably in line with the statement of Tony. No, it's what we call as the people-centered early warning system, which is composed of 4 components, main components. 1 is yung knowledge building, educating the people. 2 is the monitoring of the hazards agency. Number 3 is yung communication of the imminent hazards. Media should be involved, and also capacity building of the people in the community. So all of those must work, no? Kasi no matter what the agency says, if the people don't understand, they don't understand where to go, after when there's a warning, then everything becomes useless. No? So it's very important that our concept of the early warning should not be just the concept of, ayan na yung warning na sinabi ng ganito at a certain time. It is really long term. We need to educate the people. We need to build their capacity. We need to have proper communication of the information. If possible, embed that into the belief system, into the culture of the community. No, kasi science must be embraced by the people in the community. Otherwise, it's going to fail.
All right. Thanks, Mahar. I know you have to go. Thank you again for joining the discussion this morning. Thanks.
CP,
Yeah.
CP, may I say a little bit more?
Sige. And then,
Before my name, you see CCSDN, Climate Crisis and Sustainable Development Network. That is a new organization that we built out of what we had as MAP's Sustainable Development Committee. It became quite big, so and MAP wants to focus only on the climate crisis, but we say that it has to go with development, so we spun it off. Now, we are very much interested to pilot this in an area because I really believe, I agree with the previous speaker that this must be area focused, and I agree with Tony, this must be people focused, because the risk perception of the people is very important here. No, you can give all the warnings that you want to. You may have a perfect assessment technology, etc. But if the people perceive the risk differently, then your warning will not go far. And so I would like really to focus on one, as an example, one local community and work on it. This is my doctoral thesis, no, on warning systems. And so I will be happy to work with anybody who is interested to pursue this.
Okay, thanks, Cora. Paki-chat yung email mo sa chat box so that people can reach out to you and to CCSDN. Thanks, Cora.
Okay, CP. I would like to mention a very successful and reliable early warning system in Dumangas, Iloilo. They have the so-called field school. They also have where they train all the stakeholders, and they also have their own forecaster that has been trained at Pag-asa, helping in the forecasting system. And they also set up their own radio station, okay, that broadcasts all these forecasts. So I think vulnerable in our country. Thank you.
Thanks, Enoch. At this point, I also like to recognize Tito Aliga, who joined us in this fireside chat. Tito is the executive director of EarthFee, in the UP College of Engineering. Hi, Tito.
Thank you, CP. My connection is very bad, so I was not able to join you right
That's
away.
okay. That's okay. Anyway, naka-record yung buong fireside chat natin.
Thank you.
Okay.
I only did kasi na we have a lot of prior experience, but it seems people don't learn from that experience. Ganun pa rin, balik same area, etc., etc.
I know, hindi lang yan sa disaster resilient, pero in all aspects. I don't know. Maybe we
I
should
don't-
ask Dr. Fabella, bakit ba medyo matigas ang ulo natin sa learning all these things? Is
Yeah.
it cultural or
Or they
is
don't.
it partly because our memory, no, only is within each lifetime. There's no institutional memory.
Yep.
Kaya
Anyway, that's just my
Most
comment.
of the fatalities associated with disasters largely informal settlers.
correct.
That the problem is, for example, in CDO, the floodplains became residential, contrary to the ordinance of the city. And many people died there, but these people remain poor. Where will they go? They will still return where residential cost is lowest.
So you're saying
So-
there's no option for them.
There's very little option for them.
Yeah.
So I relate this to the comment of Raymond. Our failure to respond to average disasters many times are actually man-made, policy-made disasters. Also makes the cost of disasters higher, add on to the cost of disasters. For example, one man-made disaster is the Comprehensive Agrarian Reform Program, where land was subdivided to such small scales that they are no longer economically viable.
Yeah.
Large farms have many advantages associated with it. It really consolidates the risk for many households. It is able to adopt technology because technology is costly, and therefore it's much more economically viable. So the problem is that the drop in productivity of land is not drastic. It's not like a tsunami. No, it's slowly, and eventually you realize your agricultural sector is gone. But because they are so poor, that is where the irresilience is the highest. And so we have to take care of both the average, especially man-made disasters, as well as the real big disasters that where you are, we have tremendous experts on. So if people remain poor, they will go back to a system that they can afford, and the system they can afford are generally high risk.
Thank you, Dr. Fabella. Okay, for everyone, there's a good article of Dr. Fabella in, I think, Business World Online.
Yes,
About the title is super catchy, sir. Double dead agriculture. So just search those terms and you'll get to that article. Thanks, sir.
Thank you.
Al,
Although
were
I
you
cited
raising
that-
your hand, and then Glenn? Yes, Al. We only have 3 minutes left, by the way.
Quick comment lang for Dean Ino on the crop insurance, because we had one experience with one of the startups coming out of UP, Capital, where they were able to connect with DA to provide crop insurance to their loans to the millennially sourced capital free of the insurance, because they got the money from DA that came out of the bucket coming from the Agri-Agra penalties paid by the banks. So libre na to actually technically if you can facilitate the application kung ikaw yung loan entity. So it's still the biggest problem for me and being able to administer is how to scale it up. So I've talked to CARD, Center for Agricultural, with Dr. Alip before. I talked to several other developers on the agricultural space, but it's still not institutionalized. Pero nagawa na. Pag umutang ka sa capital ngayon, binigyan ka ng 5 or 10 million, they've loaned more than 100 million already. So hindi na rin pipitsugin over 3 years. I've been mentoring them for 5 years. But they already have the digital footprint to capable to implement it. The challenge is, of course, the scale up. So I wanted to do sana with CARD for a couple of billions na niloloan nila yearly. But because the pandemic happened, hindi kami natuloy because it was an award.
Yeah. Al and Giselle, we may have to do a fireside chat again on agriculture
Oh,
at some point in time.
well, we have one for everyone's information. Next week, we have 2 fireside chats. I'm trying to get journalists to guest in a chat on Wednesday, and I would like to invite national scientist Raul Fabella to join, Mahar Mangahas, and a few others. And then on Thursday, we have the fireside chat on national scientist Emil Javier's Lifting the Bottom Half, a Reprise. That is a discussion on agriculture, and it's timely because the Coconut Levy Fund has been released. So I'd invite all of you and your constituents and your groups to join the 2 chats next week.
Ang ganda nung speech ni Dr. Javier when he received the honoris causa. It was very revealing of his sentiments. So look for that as well online.
So
Challenge is let's implement it, CP.
okay.
CP,
So-
may I respond to Al's question?
Yes, Ino, and then Glenn, you wanted to say also something. Sige.
Just very
Ino,
quickly.
Okay, Al, the pre-insurance premium is actually part of the bait to encourage participants to get, and that's built in the loan. And that's been the practice also of PCIC. The farmers actually get insurance because that's part of the loan agreement. Okay, so we want to change that. We want to improve the estimation of the risk so that we can give options to farmers and also lower the insurance premium. Thank you.
Thanks, Ino. Incidentally, in our chat box, Mike Promentilla wanted to ask if we are going to rate our LGUs in terms of their capacity and response to the climate crisis. What grade will you give Tony and Dr. Fabella from 1 to 10, 10 being the highest?
Do we answer that?
Try lang. Definitely, it will vary from LGU to LGU, but where are we in that scale? Very far from maybe
Yeah.
5.
There are those that are more advanced in adapting structural adaptation. So they have of course flood infrastructure management, etc. But there are those that because of lack of resources, certainly, and because of lack of access to the kind of technical and scientific information that is needed in order to make those decisions, there's a huge gap there. So
I guess
yeah.
I guess the key here is, Mike, to not only look at those who are pretty far in terms of development, but actually lifting the bottom half. Those who are really requiring a lot of technical expertise, this is where we should concentrate our effort to.
CP, if I can just add to that, no?
Sige.
The cities kasi are of course the ones that are in the spotlight because they're highly resourced, they're dynamic economically, etc. But they really are linked to regional development patterns. And if we're not able to address regional development, the cities themselves will struggle at some point. So I think the way we view the designing of our interventions really needs to take, again, not just the political administrative boundary into consideration, but the surrounding municipalities and cities that are linked.
Province-wide.
Exactly.
Yeah, definitely. Okay, thanks. Glenn?
Yeah, just very quickly because maybe it's quite important. In addition to what National Science Library was talking about, this is about Cagayan de Oro. They built this, what they call those settlements, inside the river of Cagayan de Oro River. We call it Isla de Oro. During that time, new mayor came in 1998, and then maybe 4 years after, they put up those new villages, which are inside the river floodplain, about 4 to 5 meters above sea level. And the city is about 10 to 12 meters above sea level. In any case, that was also motivated because there was some interest, business interest. The city bought these lands and then put in those settlements inside the river. But on top of that, since for 10 to 15 years before 2011, that was Typhoon Sendong, the southern hemisphere, we have drought. Australia was in drought. So no typhoons really went in Mindanao. So people forget that. But 20, 30 years ago, there were plenty of typhoons in Mindanao. But since 1995, if you look at the Manila Observatory data, up to 2010, 2011, no typhoons. So people forget that also. So it's
Yeah.
a compendium of these things, you know. But if you are in Cagayan, because I come from Mindanao, there are really high lands that people could have made the city could have set up the settlements, you know, way up in the a little bit
Yeah.
in the uphills of you know, this area in Lumbia and so on, you know, the old airport. And
Yeah. And
maybe-
Glenn, also remember that they were able to title those floodplain areas of the river because
Isla
they
de Oro.
simply applied the rule of the 5-meter easement from the river,
Yes.
even if they are flat, no, almost at the level of the river.
But that's
Kaya
what I'm saying, that it's
napatitulo.
they're really sandbars. That's why they called Isla de Oro. They thought they were islands in the river. But actually, and people forget that, you know, 10 years ago, 15 years ago, from 2011, those were flooded. They were
Underwater.
flooded.
Yeah,
They were underwater. You know. But
yeah. And we
after
just
10 years,
forgot.
people just forget about that. You know,
I know, I know.
that they are
Kailangan
really
natin
part of the
siguro
river.
ng more scientists in the LGUs. Maybe Al, in your horizon, you might
Yeah.
consider becoming a mayor or governor.
But you know, in 1960, I was Xavier University high school student, 68 to 72. That area, even all the way to Divisoria, gets flooded every now and
Yeah,
then.
yeah.
You know, it's crazy.
Okay. Thanks,
Thank you.
Glenn. And just to remind Cora, please send us your email address via chat for those who want to reach out to CCSDN. Okay. We come to the end of our fireside chat. I'd like to call on the president of PAASE to give a few words, maybe invite our audience to the next fireside chat. Go ahead, Giselle.
Yes. CP, thanks. I'd like to thank you everyone, our excellent speakers, for sharing your knowledge. Also, thanks to our participants and those who provided comments and questions. I think it's important to let you know that the National Research Council, led by Tony, the UP Resilience Institute, led by Mahar and Ino, and PASE, represented by me and CP, were all invited to contribute to a USAID NOFO on climate resilient cities. And we have a meeting tomorrow. So normally we have a chat and we try to move forward, say, with a position paper, or we're doing a chat because we have a project, ongoing project in PASE. So in this case, our discussions will contribute to the proposal that we are submitting to the USAID with Arizona State University. And I informed the PASE board about this, and I will bring to the fold our specialists in the NAST as well. Well, it goes without saying that people like Raymond, Michael, Prometilla, and others would contribute to this effort through, say, the PASE. So thank you so much for your contributions. And I hope that I can share with you the screen for the PASE event tomorrow. Unfortunately, some of us...
Ako na lang mag-share.
Ayan, o sige. O, ikaw na mag-share.
There you go.
There you go. Michael Promentilla is speaking. So is Joey Ocon and Julius Liaño.
This is for tomorrow.
Yes. Sorry, Mike. I will not be present. Neither will CP and Mahar because we have this meeting. But please, everyone, join us, especially the engineering experts from NAST, as well as from UPD, EarthD. So
I'll try to catch Mike's presentation tomorrow.
But in any case, we don't lose anything because we are always posting the recordings of our chats on the PASA website. So just take a look at these brilliant young scientists and engineers who are members of PASA, who would like to share their research with us. So everyone, thank you so much for joining us today, hopefully tomorrow, and next week. And as Raul, I hope you say yes to joining us on Wednesday with our journalists and columnists. Yes?
I will look at my schedule. Baka naka-ano ako eh.
8:30 po.
8:30. Okay,
Yeah.
I will very best college try.
Thank you so much. CP?
Okay, thank you everybody, and hope to see you in the next Fireside Chat or in the next webinar of PAASE. Maraming salamat. Bye everyone.
Bye, everyone.
Okay,
Yeah,
bye-bye.
thanks a lot, boss.
Bye-bye.
Thanks,
Okay.
Glenn, Ino.
Okay.
Bye, everyone.
Okay. Keep safe. Keep safe.
Yeah,
And
same.
Laura, thanks, huh?
Thanks, Cora.
Thank you, everyone.
Pabelia.
Thank you. Congrats.
Me,
Thank you, Cora.
Nino, thank you so much. There's nothing like having this informal discussion, diba? It does not have to be
Yes.
very, very scholarly. Maganda yung interactions natin. And I think it's very constructive.
Thank you.
Okay, thanks a lot, Giselle, for inviting me here.
Ay, nako, Glenn. We will count
Thanks,
on
Glenn. Good to see you.
Okay, nice, CP. Nice seeing you, Tony.
Glenn for the USA.
Glenn.
Yes.
Be in touch.
Just email me if you like.
Raymond too.
Okay, bye-bye.
Thank you so much, everyone. I'll end it now.
Bye, NS Pabelia.
Oh, thank you as always.
Welcome, Giselle. Good to see you.
Yes. Okay. Thank you. Bye-bye.
Bye.